Then we have a short section about the factorial. So far we don't need this notation yet because it's just a way of dividing things into when do we multiply, when do we add, right? But from now on, we need this notation of factorial to do some math. So first let's introduce it. What is a factorial? In the simplest form, it is a new notation, not just a new math. We invent more notations so we can sell more math textbooks. That's a joke about that. But yeah, in theory, we start from studying this permutation and combination, and notice that maybe it's easier. It would be much simpler if we use this notation. And so we introduce this notation, factorial. In the simplest form, it is a product of all the integers starting from that number and all the way down to 1. Oh, something is missing there. Like it's missing dot. So there are more numbers there, not just these 5 numbers. So you multiply n to n minus 1, and then multiply that by n minus 2, multiply that by n minus 3, and so on and so forth all the way down to 1. So that's the definition. For instance, if I ask you to find 2 factorial, 1 factorial, it's just the number 1. 2 factorial means you start from 2 and you multiply that by everything else all the way down to 1. And everything else is just 1 because the next number below 2 is already 1. So we stop here and we get 2 times 1. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. And this pattern continues. You can have 10 factorial. That will be number 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 all the way down to 1. And then you can use your favorite calculator to compute that number. It should give you 25,200. I think, if I'm not wrong. Let me make sure that I'm not. Oh yeah, I'm wrong, but yeah, you get the idea. I think at least 36,020. Yeah, something like that. It's a large number. And whenever you see a large number, you can kind of have an idea that it's not important what that number is exactly. Like it's not important what the base 10 representation of that number is. Like what's important is the concept about what we are doing. We multiply things together to get a single number out. And yeah, that's a big number. But we will use that soon. And some notes about the 2 numbers. It says first that you can here we define them as repeated multiplication. Okay, but there's a better way to define that, which is in terms of I think this is called recursion. So in this case we define n factorials in terms of n minus 1 factorial. So we define this number in terms of the smaller number. And then if you ask what is n minus 1 factorial, you have to repeat that process again. So for instance, if you want to find 10 factorial, if you use this notation, it means it is 10 times 9 factorial. And if you ask me what is 9 factorial, then yeah, you repeat that same thing. 9 factorial is, it is 9 times 8 factorial. What is 8 factorial? Oh yeah, 8 factorial is 8 times 7 factorial. Oh, what is 7 factorial? You see the pattern here, right? You have to repeat that you repeat that whole process. But eventually, it's gonna give you the same result, which is 10 times 9 times 6 times all the numbers down to 1. And then you might ask, wait, why do we have to divide that in this way? That sounds kind of weird. And because to know 10 factorial, you have to know 9 factorial. To know 9 factorial, you have to know 8 factorials. And it seems like we kind of like postpone or we procrastinate the computation of 10 factorial like to 9 factorial. It's like, no, we have to repeat this over and over. There are 2 or 3 pros or benefits of defining factorial in this way. Like first, it is better in terms of it is well defined. Why is it better than the previous notation? Like because if you look at this notation, and if you ask what is 1 factorial, and if you look at this notation, like what I'm writing on the screen, you would think that 1 factorial needs to include 2, right? Because it has 2 in this formula. It needs to include 1 minus 1, which is 0. It needs to include minus 2. So it seems as if 1 factorial is 1 times 0 times minus 2 times ... times 2 times 1. Which you can see this is nonsense, right? Like this formula is nonsense. It doesn't make sense for some of the numbers. So yeah, this is, even though it seems easier to describe, yeah, it fails in some cases. So yeah, this is not a good formula to use. And yeah, it is better to just define it as, okay, you have a number and then you repeat the same process over and over again. Yeah, so first it is well defined. Because it only involves 2 numbers at a time. Like we don't make an assumption that it will go all the way to 2 and 1. Because 2 may not exist. And second, like this is actually the way you compute things. Because if you go back to this 4 factorial, right? If you want to compute 4 factorials, then yeah, you can just plug that number into your calculator, and you smash the buttons 4 times 3 times 2 times 1, you get 24. Right? But if you take a look at the formula, you could say that, why don't we just use what we have already? Yeah, to compute 4 factorial, you can use 4 as a new number, and you can multiply that by the result we already have. Like in terms of computation, that will save lots of times. So yeah, you can use what we already have, like in terms of programming, in terms of recursion, like that saves time. That saves time and energy, so that you don't have to do everything over and over again. You can use what we have and just multiply that by the n, multiply that by the new number to get a new result. So yeah, that's better in terms of recursion. And also in terms of like coding or other stuff, when you have to think about recursion, factorial is the easiest, one of the first examples when you start coding. So yeah, this is better in many ways, and at some point I recommend you use this definition instead. And another note here, like you can see there's some interesting going on here. Like because by the way this factorial is defined, like we first defined it for positive integers. Because only the positive integers work in this formula. But sometimes you will see 0 factorial in several cases, and even though it seems like it doesn't make sense, because you cannot multiply 0 by, you can multiply 0 by the next number, which is minus 1, and so on and so forth. But that means you would go down forever. Like you would never reach 1. So in a sense, 0 factorial doesn't make sense, like to define in terms of multiplication. But The reason we need to define zero factorial is, first, it actually makes sense in some context, which we will explore sometime soon. It makes sense in some context. It makes sense in other context. It doesn't make sense if you think about repeated multiplication, but in terms of a formula, that works. And second, zero factorial actually shows up in this alternative definition. Because if you plug in n equals to 2, this formula says, oh, it is 2 times 1 factorial. Makes sense, right? What about 1? If you plug in 1, what do you get? You get 1 times 0 factorial. So if you extend this definition to work on all positive integers n, then you can plug in n equals to 1, and you get this weird looking formula. That means that must have some kind of value, right? Then what is on the left hand side? What is 1 factorial? We should all agree that 1 factorial is 1, from the author definition. Then that means this equation says 1 equals to 1 times 0 factorial. And if you do the math, then it should be clear that 0 factorial must be 1 for this equation to work. For this definition to work for all the positive integers n. So yeah, there's a formula that justifies this definition that 0 factorial is 1. It also makes sense in other contexts. Definition. It actually also makes sense in terms of math. If you add nothing, you should get 0. In terms of addition, if you add nothing at all, you should get 0. But if you multiply nothing, if there's nothing to multiply, then the default is not 0. The default is 1. Because if you make multiply nothing to be 0, then once you modify the first thing, then that should be 0, right? If you say that, okay, if you do nothing, you get 0. If you multiply the first number, then that first number multiplied by nothing is 0, which doesn't make sense. And so nothingness in terms of multiplication should be 1. It makes sense to be 1. So that when you multiply the first thing to the list, you get that number. And again, in terms of the code, if you declare the default number in terms of multiplying things, it should be 1. And then you do the for loop, and a equals to a times n. And it makes sense to make a be 1 in the first place. And so that's a definition of a factorial and some fun facts about them.